You ever get the feeling that numbers have their own secret language? Like they're full of hidden patterns and codes just waiting for someone to crack them? Well, you're not wrong. Today, we're going to pull back the curtain and learn how to speak that language. And we'll start with something that looks a whole lot like magic.
So to get us warmed up, we're going to do what feels like a magic trick. But I promise you, by the time we're done here, you'll know exactly how it works. There's no smoke, no mirrors, just the pure, beautiful logic of numbers.
All right, I need you to play along with me on this one. You can grab a piece of paper or just do it in your head. It's super simple, but trust me, the result is pretty cool. Okay, step 1. Think of any 2-digit number, anything you want. Got it? Good. Now, step 2, reverse the digits of that number. So if you picked, say, 27, you now have 72. And finally, step 3, add your original number and that new reversed number together. Go ahead, take a second, and get your final answer. Okay. You have your final number. Here's the crazy part. I can guarantee 100% that whatever number you're looking at is perfectly divisible by 11. Go on, check it with a calculator if you don't believe me. So, how did I know that? It's not magic, it's math, and we're about to crack the code. So, how is that even possible? How could I know the property of your number without knowing the number itself? Well, the secret is in understanding how numbers are actually built. It's a concept called the generalized form, and believe me, it is the key to everything we're doing today. Now, I know that sounds a little textbooky, right? But the idea is actually really simple. It's just about breaking a number down into its basic parts. How many ones it has, how many tens, how many hundreds, and so on. And this visualizes it perfectly. When we see a number like, say, 68, our brain just sees 68. But what it really is, its architecture, isn't 6 times 8, of course not. It's 6 tens plus 8 ones. And in the language of algebra, we write that as 10a plus b. That right there, that's the blueprint. Honestly, the best way to think about it is like this. The generalized form is the secret DNA of a number. It tells you exactly what it's made of, its fundamental structure. And once you know that, you can do some amazing things. So this is it. This is the big one. If you only remember one thing, let it be this little formula right here. AB equals 10a plus b. Because this isn't just a formula, it's the master key that's going to let us unlock all kinds of number puzzles. Okay, so we have the key. Now let's go back to that opening trick. It's time to apply our new code-breaking tool and see exactly why it works. And we might just uncover a few more secrets along the way. So remember what we did? We took a number, which we'll call AB, and we added its reverse, BA. Now, using our secret DNA code, we can rewrite this. The number AB is really 10a plus b, right? And its reverse, BA, is just 10b plus a. So all we did was add those two things together. And check this out. This is where the magic happens. When we add 10a plus b and 10b plus a, we just combine the like terms. 10a plus a is 11a. b plus 10b is 11b. So we get 11a plus 11b, which is the same as 11 times a plus b. And there it is. No matter what a and b are, the result is always a multiple of 11. But now look what happens if we subtract them. A completely different pattern emerges. We get 9 times a minus b. So we've just uncovered 2 golden rules for any 2-digit number. The sum of a number and its reverse is always, always divisible by 11, and the difference between them is always divisible by 9. That's a pretty powerful pair of secrets to have in your back pocket. All right, you're doing great. It's time to put these new skills to the test with the ultimate challenge, something called cryptorhythms. Think of them as coded messages, and we're the code breakers. The rules of the game are simple. Each letter you see stands for a single digit, from 0 to 9. The trick is, each letter has to be a unique digit. So our mission, should we choose to accept it, is to use pure logic to figure out what number each letter represents. Okay, here's our puzzle taken straight from the source material. We have 31a plus 1a3 equals 501. We need to find the value of a. So, where on earth do we start? Well, with puzzles like this, you always want to start where you have the most clues. And that's almost always the far right column, the ones column. Let's look at it. We see that whatever a is, when you add 3 to it, you get an answer that ends in the digit 1. So let's just think about that for a second. What single digit can you add to 3 to get a result that ends in 1?
Well, the sum can't be just 1, right? Because that would make a negative number, which isn't allowed. So the only other possibility is that the sum must be 11.
And boom, there it is. If a plus 3 equals 11, then a little bit of simple subtraction tells us that a has to be 8. And just like that, we've used nothing but logic to crack the first part of the code. Pretty satisfying, right? Okay, before we finish up, I want to leave you with a really practical toolkit. These are super simple tests you can use to see if a number is divisible by another one, without actually doing any long division. They are fantastic mental math shortcuts. So here's your cheat sheet. Now, you probably know a lot of these already. Checking for divisibility by 2, 5, or 10 is easy. But look at the rules for 3 and 9. It says to just add up the digits. Why does that work? Well, it goes right back to our number DNA. Take a number like 351. In its generalized form, we know that's 300 plus 50 plus 1. We can rewrite that as 3 times 99 plus 1, plus 5 times 9 plus 1, plus 1. If you expand that out, you get a bunch of numbers that are clearly divisible by 9. And what are you left with? Just 3 plus 5 plus 1. That's why the rule works. It's a hidden feature of our number system.
And that's why this matters. These aren't just abstract rules for a math class. They are genuine shortcuts that can speed up your calculations and just give you a much better feel for how numbers work together.
So, what we've seen today is that numbers aren't just for doing sums. They're a playground filled with all these incredible patterns and puzzles. We've only unlocked a couple of their secrets. The real question is, now that you have some of the keys, what other codes are you going to discover?